Now we're going to do another few examples with enlargements, and I want to talk about what happens when the center of enlargement is actually on the object itself, when it's one of the vertices of the object. So we've got a triangle like this called ABC. So this is my original triangle here, ABC, where AC is 6 centimeters. And we construct an enlargement of ABC called A prime, B prime, C prime. And what we've done here is that this vertex down here is the center of enlargement. So this vertex is the center of enlargement. And what you can see is that when one of the points that are on the original shape is used as our center of enlargement, then the object will actually contain the image will contain the object. Okay, so the object is contained within the image. The object is contained within the image. So a little bit more information that's given to us is that the distance from C to C prime is 9 centimeters. And let's write down some more information that we're told. So in this diagram, the triangle A, B prime, C prime, okay, so we're just going to use A, we won't bother using this. A, B prime, C prime is an enlargement of the triangle ABC, where A, the vertex A, is the center of enlargement. If AC is equal to 6 centimeters, which we've already marked in here, C to C prime is 9 centimeters, which we've also marked in here, and B prime to C prime is equal to 12.5. Find the following things. So we haven't marked in the 12.5, and that's often how these questions come up. They put some of the information on the diagram and they leave some of it for you to do yourself. So we'll mark that in, 12.5 centimeters. So the things that we need to find then, what do you think? Of course, they're going to ask us for the scale factor of the enlargement. That's K. And then the next thing they're going to ask us for is one of the missing sides, this side here, the length from B to C. And the third thing we're being asked for is the ratio. Now, ratio just means put one of them over the other. AB is to AB prime. So if you've forgotten how to do ratios, don't worry, we're going to go through that in a second. Okay, so we're not used to seeing enlargements stuck together like this, so it's probably useful for part one. The first thing we're going to do is just sketch out our triangles side by side. So I have it doesn't have to be a particularly accurate triangle. I've got the triangle ABC, and I have the enlargement of it, A, B prime, C prime. And then I mark in the information that I know. So I know that this is 6, and I know that this is 6 plus 9, which is 15. 15 centimetres. I know that this is 12.5, and I know that later I'm going to be asked for this. So now I can work out my scale factor. What did I multiply 6 by in order to get to 15? So for part 1, my scale factor, K, is going to be 15 divided by 6. And you can leave it like that if you want to, and leave it as a fraction, 15 divided by 6, 5 over 2, or you can write it as 2.5. So my scale factor, because that's a nice neat decimal number, I might leave it as a decimal number. It's sometimes easier to put into your calculator than fractions. So 2.5 or 5.2 is my scale factor of the enlargement. The second thing I'm asked then is to find BC. What did I multiply by 2.5 to get to 12.5? So x is k by 12.5. No, k times x, sorry guys. 12.5 is k times x. I multiplied that by that. In any case, to find x, because we know k, x is going to be 12.5 divided by 2.5. So 12.5 divided by 2.5. Divide by my scale factor and I get 5 centimetres. So B to C is 5 centimetres. There's no units on the scale factor because that's a scalar that we're multiplying by. And then part 3, they want the ratio AB is to AB prime. Well, we have no numbers here, okay? So how do we do it? Well, what this is asking is, what do you get when you divide one side by the other? And what they're relying on here is the fact that enlargements multiply all sides by the same amount. So if they're asking you for the ratio from AB to AB prime, that's the same as any of the other sides. It's the same as the ratio of AC to AC prime, which is the same as the ratio of BC to B prime C prime. Okay, object is to image is constant. Object to image is the same regardless of which side we pick. So what's the calculation then? Let's just pick this one. So this is going to be the same as 6 is to 15. Now how do we, excuse me, how do we simplify ratios like that? Well, put them into your calculator as fractions and let it do the hard work for you. 2 is to 5. So the ratio is always the same regardless of which pair of sides we're using. Hopefully that's nice and clear and you understand what we're talking about there. So do take that down into your notes copies. A lot of writing there. Let me know if there's any step that you're not quite sure on, and we can add extra notes on that if necessary. Thank you.